So in today's class, we'll continue from convex lens. Understand? So in yesterday's class, I have told you what is the rules obtaining to form the images formed by convex lens, as well as we have seen that the different images formed by the convex lens when we are facing the object, placing the object at different locations in front of the lens. Understand? So totally we have studied 6 cases. If we place the object between optical center and focus, next at focus, next between F1, F dash and F dash, next one at F dash, next one B F dash, next one at the infinity. Like that, 6 different cases I have taught you. So if you are placing the object at somewhere, then what is the image will form? What is the characteristics of the image? That is all we have studied. Is it yes or no? Yes?
Yes, sir.
Yeah. That is what we have studied in the last class. So, if it comes to there, so every case, understanding, either it is virtual, either it is real, what is the understanding, what is the location of the object, either it is positive or negative, that is all including the sign convention we have studied. I hope you are also very clear in that. So if you have doubt, still you can ask me, it's not an issue. And now we are going to study, understand. So, what are the uses of convex lenses? What is that? Uses of convex lenses. So now, if it comes to the uses of convex lenses, so as we know that convex lenses will form both virtual and real image. Is it true or not? Yes or no? Yes. So, so you have to know the what is the uses of convex lenses. So basically we have 4 uses of convex lenses. So one of the main uses which we are going to study in the next chapter called as convex lens we can use to correct the defect of vision called as, what is that vision? Uses of convex lenses. You can keep adding. Uses of yes. Somebody is speaking. Okay. So if it comes to the first use of convex lens, it is used in. Please stop. Who is that? Some boys. So it is used in. It is used to. It is used to correct defect of vision called as defect of vision called as hypermetropia, or we can call it as long-sightedness. Do you understand? That is the first use of this one. Next one. Can anybody say? We can use in simple cameras. It is used in simple cameras, microscopes, film projectors, etc. Next, it is used in where? Magnifying glass, by used as a magnifying glass by palmist. Palmist means Ura. Who is palmist? Palmist means whom? Yesterday I have told you, correct? Nobody is saying. Who can see the lines in palm? Who is to called as palmist? Yeah, palmist. Write it, all of you. Magnifying glass used by palmist. Magnifying glass used by palmist. Note it down. Next, watchmakers, etc. Palmist, watchmakers, watchmakers, etc. So this is what the uses, 3 uses of convex lens. All of you noted down. 3 uses of convex lens. Is it any doubt? You can ask me. You must know the uses of concave mirror, convex mirror, as well as convex lens and concave lens. I hope you have noted down. And you may remember, if you want, you can split the second point into 2 points. It is used in a simple cameras, 1 point, and also it is used in microscopes, film projectors. Like that, you can write 1 more point. So that is all the 3 points or 4 points regarding uses of convex lenses. Understand? So you can use it. Even telescopes also we can use. Understanding? Microscopes and telescopes. So this is all about the uses of convex lenses. Understanding? So if you'll understand this, then I will give you one question. Then we will go it. Okay, da? So let's say the question, all of you. Are you ready?
Sir.
Yeah. So get ready with the question. So let's see seconds. Within a second, you should say. I will see that. Don't answer. Just let finish the question first. Write the question, all of you. An object placed at the following distances. An object placed at the following distances. An object placed at the following distances. Question. An object placed at the following distances of a convex lens having focal length 10 centimeter. Having focal length 10 centimeter. So that is what the question. Understanding, right? So now following distances. 8 centimeter, 15, 20, 25. 8, 15, 20, 25. So A 8 centimeter, B 15 centimeter, C 20 centimeter, and D 25 centimeter. So these are the 3 things. All of you should remember exactly now. So now questions. Roman number 1. Can you able to understand, all of you? Yes or no?
Yes, sir.
Now, write the questions. First one. Diminished real image. Diminished real image. Don't think also. Next. Magnified virtual image. Next. Magnified real image. Next. Same size of the object. Same size like object. So okay, what is the options? A, B, C, D. Fastly. For everyone, you should say the question. So getting the diminished real image where we should, magnified image where we should, magnified real image where we should set, the same size where we should set. Fastly. Don't take more than, understanding, 5 seconds. If you take more than 5 seconds, then no use. So which position will produce? Which position? Diminished real image. Arey, what is this? Diminished real image position.
Object in 25, sir. Object in 25.
You have studied 6 cases.
So 25 centimeters, sir.
25 centimeter.
Which case will position?
25 centimeter.
Diminished real image.
Diminished real image. What case? Diminished real image with the position of behind C. Is it yes or no, ma?
24
Yes, sir.
centimeters.
Yeah, beyond C. So beyond C. Beyond C means here how much C? Here how much C?
20.
C equals to 20 because F is equals to, they have given F dash equals to 10 centimeter.
Yes, sir.
Sorry, F, not F dash. F is equals to 10 centimeter. F dash.
So C is 20 centimeter.
2f dash, not cm. 2f dash is equals to
Okay, sir. Okay, sir.
centimeter. No, C means optical center. Here, not there. So,
Okay,
if,
sir.
here, if you want to get the real and the diminished image, so where we should place the object? Which case? Case number 5. Is it yes or no? Case number
Yes, sir.
5.
Beyond
Place,
to
yeah,
us.
place the object beyond 2f dash, then the image will form a real magnified, real inverted and diminished image. Is it yes or no?
Yes, sir.
Yes,
That is
sir.
what you should remember. So which case it is now? So here focal length is 10 and see 2f f is equals to 10, 2f equals to 20 and more than that means 25. Very good. So beyond 2f dash means option D here, 25 centimeter. So next, magnified virtual image. Magnified virtual
8
image.
centimeter. 8 centimeter.
Magnified virtual
8
image.
centimeter.
8 centimeters.
8 centimeter.
Optical center C. RO. Is it yes or no? So means
Yes, sir.
10 centimeter.
It will form virtual image.
Centimeter means it is 8 centimeter. Next, magnified real image.
When magnified real image
15
is
centimeter.
15, sir. 15
Yeah,
centimeter.
between f dash and 2f dash means which is equals to 15 centimeter. Next,
Middle of 2f dash
exactly same
20
size,
centimeter
20
20
centimeter.
centimeters.
at 2f dash.
which is equals to 20 centimeter means in the sense of option C. Do you understanding all of you?
Yes, sir.
All of you note it down. So DA, BC will come. This is what fastly you should say. Can you able to understand others? Are you able to find it or not? Arvind, Padmavarshini?
Yes, sir.
Everybody
Yes, sir.
must remember that. Dina, do you understand Dina? Pranav?
Yes, sir. Understood, sir.
Okay. So like that you should find it. Still somebody is absent. Please make a call for them. Okay. So now this is what the question. So I hope you understand very well. So if you understand this, then we'll go for next question. Understanding. So next concept is, so as we know that what is the next type of lens? What is the next type of lens?
Concave lens.
Concave lens.
Lens. Understand? So all of you keep heading concave lens. Concave lens. Or else shall we finish these numericals in this convex lens? Few numericals. Okay, let it be. Let's finish this both. Later we will do it. That is better. Do it. Right next. All of you keep it. Concave lens. Next, what will come first? Rules for obtaining images formed by concave lens. Rules for obtaining images. Rules for obtaining images formed by concave lens. Rules for obtaining images formed by concave lens. Concave lens. So concave lens means what? Bulges at surroundings and thinner means
Thinner
thicker.
at the middle, sir. Thinner at the middle.
Here at the middle, sir.
Thinner at the middle. That is what. So all of you should note it down that. So it is what it looks like this. Understand? So now this is one concave surface and this is another concave surface. So exactly middle if you draw straight line, it will be equals to what? Midpoint of that optical center.
Optical center.
That is understanding. So now let us see the rules for obtaining images formed by concave lens. So as we know, concave lens means also we can call it as what? Diverging lens. Is it yes or no? Yes,
Yes,
or no?
sir.
So diverging lens. So as we know that if we insert the parallel beam of light, understanding parallel beam of light, what will happen? All the light rays will diverge away.
Diverge.
Divert away from the lens. Understanding? And we will feel them. They will coming from where? We will feel them. They are coming from virtual focus. Correct or not? If you extend them in a backward direction, so they will meet somewhere at the focus. So that is what we used to call it as understanding. So that is only we used to call it as virtual focus. Is it yes or no?
Yes, sir.
So that is we used to call as f dash and f and 2f, and this side we have f dash and 2f dash. That is what we have studied. So this is the focal length of understanding. Concave lens. So concave lens also we can call it as what? Diverging lens. What?
Diverging lens.
Diverging lens. All of you should remember. So now let us see what is the rules for obtaining images formed by concave lens. So here before that I will say one thing. All of you should remember concave lens will never form which image ra? Never form.
Real image.
All of you should remember. Never form real images. Always it will form only
Virtual image.
virtual. Understanding? It will form only virtual image. Only virtual image. That is also in the which coordinate ra? Anybody is fastly smartness? Which coordinate? Virtual image always will form in the case of lens.
Here minus x-axis,
That is
x dash coordinate, sir.
First coordinate. So here alone the virtual image will form always. Understanding? Means minus x coordinate, and that virtual image is also always a diminished image. What is that?
Diminished.
Diminished image. Blindly you should remember. So from this I can say V is always negative or positive. V is always negative or positive.
Negative, sir.
Negative.
Whenever you will see a concave lens, our brain should say that, understanding, f is equals to negative, understanding, v is equals to also negative, and u is equals to also negative, and only magnification is alone positive. Magnification is alone positive. Do you understand?
Positive.
Yes
Yes,
or
sir.
no? Next, height of the object is also positive, and height of the image is also positive. So this is the things which our brain need to say when we are studying about concave lens. Immediately the 6 sign convention need to remember. So the 6 sign convention is always fixed. Always fixed. Understanding? For concave lens, no change in it. Will you able to remember, all of you?
Yes,
What I'm
sir.
saying? So this Jesse, Pranita, Jesse is not there, I think. So these cases will never change for anything. Arvind, Nitinath is not there today. Oh, Nitinath is there. Okay. Karthikeyan, Arun Karthikeyan is also there. Somebody please missing ones you call. So this is always fixed sign convention. All of you, those who don't want, those who want, you can note it down. So focal length sign convention is always negative. Image distance is always negative. Object distance is always negative. Magnification is always positive. Height of the image positive, and height of the object is also positive. So this is what it is always fixed. Understand? Understanding, Ra? All of you. Now we will go for rules obtaining. Understanding? For forming the images formed by, obtaining the images formed by concave lens. All of you keep reading rule number 1. Rule number 1. Rule number 1. Do it now first, all of you. A ray of light which is parallel to the principal axis. A ray of light which is parallel to the principal axis. A ray of light which is parallel to the principal axis. A ray of light which is parallel to the principal axis of a concave lens, appears to be coming from its focus, after refraction through the lens. Appears to be coming from the focus after refraction. Appears to be coming from the focus after refraction. Refraction through the lens. After refraction through the lens. Note it down fastly, all of you. Do you understand, Ra? Yes or no? Now you can see here. Now you may observe here, all of you. So this is the first rule obtaining. So when you are inserting the incident ray, which is parallel to the principal axis, what is happening? Okay, Pranita, you listen. So which is inserted parallel to the principal axis, what is happening now? Speak, yeah. So if I'm inserting the incident ray, which is parallel to the principal axis, you can observe here carefully till understanding, till the mid of the lens, it is going straight line. Later it is diverging away from the lens, diverging away from the lens. So if it is diverging away from the lens, doesn't matter, but we are feeling that the refracted light ray after diverging from the lens, we are feeling that it is coming from where? It is coming from
Focus.
understanding. In concave lens, always F will be this side, F dash will be this side. That is what you should remember. And 2F here will be this side, and 2F dash will be that side. Is it yes or no? That is what we have studied. Correct or not? Nobody will say.
Yes, sir.
This is the case number 1. All of you should remember. When you inserted the incident ray parallel to the principal axis, the refracted ray after going through the lens, it is appears to be coming from the focus, So this is what the rule number 1. All of you draw. Here also the same thing, Ra. If you want to get it, focal length little bit take more. Take F is equals to 6 centimeter. This length itself you take 6 centimeter. Notebook always fix it. In our exam also always you fix this, because then the image will come little bit more clear. That is the purpose I am saying you. So all of you do that. Finish this and perfectly you should draw. I am saying you again, diagram should be very, very perfect. Nobody should commit any mistake in this. Do you understanding? So this is the rule number 1. If anybody having any doubt, you ask me. Perfectly how they are mentioning, you see, D, C, naming is most important. So incident ray is called as AD and the refracted ray is called as DX. Understand all of you? Yes or no? Yeah, all of you draw this. Rule number 1. Rule number 1. Only we have 3 rules, Ra. So these 3 rules is enough to draw image, because in this concave lens we have only 1 case. So usually 2 cases in our textbook, but that is already we know that. Understand? That is, do it fast, all of you. Anusri, is it completed, Anusri? Arun Karthikeyan. Do it fast. Once if it is completed, you tell me. Okay. Shall we go for next rule number 2, all of you? Right, rule number 2. A ray of light passing through the optical center. A ray of light passing through the optical center. A ray of light passing through the optical center of a concave lens. Optical center. Again, optical center, what will happen, Ra? Whatever the lens, what I said. Optical center, what I said. What I said, optical center, if any light going through optical center, what will happen? It will go straight after passing through the lens. That is what you have to remember. A ray of light passing through the optical center. A ray of light passing through the optical center of a concave lens. Of a concave lens. Of a concave lens. Of a concave lens will go straight after passing through the lens. Will go straight after passing through the lens. Do you understand, Ra? After passing through the lens. Is it yes or no?
Sir, can you say again?
Yeah. Right. Write it now. All of you. A ray of light passing through the optical center, a ray of light passing through the optical center of a concave lens, of a concave lens, of a concave lens, goes straight, goes straight, goes straight, goes straight after refraction through the lens, after refraction through the lens. All of you should draw. This is what the second case. So which will go straight line without any deviation. This is constant for any lens draw. Concave or convex lens doesn't matter. It is same thing. So this is only called as rule number 2. What we should call? Rule number 2. All of you should note it down. You can see here the light ray which is passing through the optical center will go straight line. Understand? Go straight without any deviation. So this is what the rule number 2. All of you draw. A ray of light passing through the optical center C goes straight without any deviation. That is what. Do you understand, Ra?
Yes, sir.
All of you do it. Varshini. Rule number 2.
Sir.
Understand? This is. So now, if anybody having doubt, you ask me. Next, rule number 3. So it is opposite to first rule. So opposite to first rule, that is what? You should note it down, right? Rule number 3. A ray of light goes, 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 goes, a ray of light goes, a ray of light goes, goes not going towards to the focus of a concave lens, going towards to the focus of a concave lens, going towards to the focus of a concave lens, going towards to the focus of a concave lens, becomes parallel to its principal axis, becomes parallel to its principal axis after refraction through the lens, after refraction through the lens. A ray of light going towards to the focus, going towards to the focus of a concave lens, of a concave lens, of a concave lens, comma, becomes parallel to its principal axis, becomes parallel to its principal axis after refraction through the lens, after refraction through the lens. That is what you should remember. So it is just opposite to the case number 1. So you may observe here, understanding. So it is just opposite to the case number 1. So that is what we can say. So when you are inserting the incident ray, which is parallel to the principal axis, which will feels that it is going through the focus. So now the same thing if you'll observe, if you are inserting the incident ray in such a way that, where it is left, yeah. So here it is there, you can observe. So this is what the things happening. So before you can see, if you insert the incident ray, understand? So we'll feel that which is parallel to the principal axis like this. Rule number 1 you can observe, and this is the rule number 3. Understanding? Opposite to the rule number 1. So rule number 1 will says that you see. So that if you insert the incident ray which is parallel to the principal axis, the refracted light ray, understanding, will feel that it is coming, understanding, from the focus. Now just opposite you imagine. If I am inserting the incident ray, which will, understanding, going towards to the focus, going towards to the focus actually. If there is no lens, it will go like this, only straight line. So going towards to the focus, understanding, it becomes parallel to the principal axis. That is what you should remember. But by this time, Here f dash is the focal length. That is what you should remember. So this side it is coming. It is the light ray which is going towards to the f dash, which will becomes parallel to the principal axis after striking the lens. That is what you should remember. So both the cases I will draw in the same image. So if we'll take the principal axis parallel to the principal axis, then after refraction, it will go away from it and will feel that the refracted ray is coming from the focus. This is what the case number 1. Now just opposite to that, that's all. Nothing is there. So that is what I am saying you. Try to do it now. Do you understand all of you? Yes or no? So these are the 3 rules which we need to obtain the images formed by a concave lens. All of you do it fast. These are the three rules which we need to use to obtain the images formed by concave lens. Understand? So usually this rule number 3 we don't have any use. Only we have a use of rule number 1 and rule number 2. Understanding? So with this itself we can draw the image of any case. So that is why rule number 1 and rule number 2 you have to remember, most important for drawing the images formed by concave lens. Understanding? So rule number 1 will says that, understanding? So the light ray which is going through the focus, after refraction it will feel that it is coming from the, understanding, coming from the focus. That is what you should remember. Next, going through the optical center, go straight line without any deviation. So this is the 2 rules. Can you able to remember, please? Yes or no? So if you are able to remember this, then that is enough. Shall we move now?
Yes, sir.
Yes. So that is what you should remember, all of you. So this is the 2 rules. Kevin, do you understand, Kevin?
Yes, sir.
Yeah. If you'll understand this, then what is the next heading? You can give heading. Images formed by concave lens. You can write it. Images, next heading. Images formed by concave lens. So actually we have 2 cases, in front of the lens and at the infinity. That's all. So means between infinity and optical center and at the infinity. Only 2 cases we have. So 2 cases we will see. So whatever, actually according to me it is only single case. Wherever you will place in front of the lens, what is forming Ra? What it will form always? What will form always? Always will form virtual image. No. So that's all. So we don't need to remember that, but we have to do it. What we'll do? Do it now. Formation of image by a concave lens. 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 Case number 1. When object is placed between infinity and optical center. 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 That is the case 1. All of you should remember. This is the case 1. This is the case 1. All of you do it.
Sir, between
infinity and optical center. Between infinity and optical center. That is. So you can observe here in this picture. All of you do it. So this is the ray diagram. So here if you observe carefully, all of you. So you may observe here. It is placed at some known distance. Understand? So I have placed somewhere known distance which is less than infinity. Means less than infinity and optical center. So you can see 2 special rays I am taking. What is that? Can you able to say? This is rule number 1. Is it yes or no? And this is what? Rule number 2. So these are the 2 rules enough. So 1 rule is the light ray which is going through the optical center will go in a straight line. So I have told you to take this is 6 centimeter correct averagely and place the object just understanding 10 or 12 centimeters like that. around 10 centimeters you place it, then you will get the perfect image. So for this case, if we draw the eye, then it is more even nice because it will increase the view. You may observe here, diverging rays it is, so that we can see the image, understanding from virtual image which will form minus x coordinate. So it is minus x coordinate. That is why we can call it as what? V is equals to minus always. Is it yes or no? Yes or no? So that is what you should remember. Understanding? So all of you draw this. This is the rule number 1. So if you insert the if you place the object between, understanding, optical center and less than infinity, means between infinity and optical center, which will form always virtual image. What is the characteristics, Ra? What is the characteristics?
Virtual erect and diminished.
Virtual erect and
Erect and diminished image. Do it fast. All of you draw neatly, perfectly you draw. Nothing will happen. Virtual, erect and diminished image. Virtual, erect and diminished image. Virtual, erect and diminished image. Do it fast. Second case. At infinity. At infinity. First you finish this, later that. At infinity. Object is placed at infinity. First you draw that image, later you can draw. Is it completed, Ra? This is the rule number 1. Sorry, image formed by concave lens. Understand? Case 1. So when you place the object between less than infinity, between, understanding, infinity and optical center, O or C. So that is what the case. Is it okay, Da? If it is completed, tell me. So all of you remember this. Next, second case. This is already we know that. What is that second case? Just like a focal length. So what will do, Ra? Case number 2. At infinity. All of you note it down. At infinity. Object is placed at infinity. What will happen, Ra? Object is placed at infinity distance. Understanding?